I see my screen. Thanks for coming. Many thanks to the university for inviting me. It's going to be a trial lecture. I'm going to share with you my thoughts about unit testing, automated testing. I have no idea who you are. I have no background about your knowledge, so that's why this lecture is going to be at the same time practical and at the same time quite theoretical. So don't expect me to show you some interesting source code, but at the same time, don't expect me to be too theoretical. Yeah, first of all, please join this channel on Telegram. I created a special group on Telegram, which will exist during this lecture. So you can join it, and we will use it for the next 1 hour and a half. You can talk to each other in this group, and I will drop there some information about what's going on. And also, we're going to have 45 minutes on the talk, and then 10 minutes break, and then 45 minutes of the practice. And by the end of the practice, we call it lab, I will give you 2 gifts. I will give you 2 books. So I brought 2 books with me. One book is written not by myself, but somebody who I respect a lot. It's a professor from America, very book which influenced me a lot about object-oriented programming. And the second book is mine. So 2 people in this room will get 2 gifts from you by the end of 1 hour and a half. Not just gifts for nothing, but you will have to work and participate in the competition. We're going to have a competition in the second part of this session. So now about testing. First of all, I'm going to tell you a little disclaimer. So I expect that you are programmers. So if you are completely not a programmer, then you better go find some other room to participate in. Second, my expectation is that you on your computer have Unix, Mac OS, or something like that. If you have Windows, then you may also have problems here today. The next expectation is that you have Git, JDK, and Make installed. So you have 45 minutes right now to install this stuff. If you don't have it, then you will have problems participating in the competition of the second part of the session. So make sure you have Git, make sure you have Make, and you make sure you have JDK, any version you want. JDK is Java Development Kit. And my last expectation, I expect you to doubt everything I'm going to say today. So don't take it as, for granted. I may make mistakes. Again, I have no background who you are, so I'm just telling you what I think, and it's up to you to believe or not. The plan for today, we will talk first about what are the requirements and releases, how I understand them. Then we're going to talk about release pipeline, also called CI/CD right now. I will share my thoughts about this, how it should be. Then we will talk about bug reports, who they are and what they're for. And then we're going to have the game. In the game, you will participate actively. You need to have your computers. What about automated testing? Through all of this discussion, we will talk about automated testing. We will actually write tests today. Some of them, most of them you will write, but I will show in the beginning how to write them. That's the plan for today. 45 minutes, 10 minutes break, another 45 minutes. So let's jump to the first step. It's requirements and releases. Let's start with a practical example. Let's say we have requirements. We are programmers. We have requirements. The requirements are called, we need to create a function that calculates Fibonacci number. Who doesn't know what is Fibonacci number? Everybody knows. So the Fibonacci numbers are integers, the next one, the next one. So every second number is the summary of the previous 2 numbers. So today we're going to write a function that calculates Fibonacci numbers, and we're going to create tests for this function. 1, 1, 2, 2 is the summary of 1 plus 1, 3 is the summary of 2 plus 1, and so on and so forth. So probably if you are attentive enough, you will see that there's a bug in these requirements. So number 9 is not 9, it should be 8. So this bug is made by the customer. So the customer provided us the requirements, the customer wants the Fibonacci numbers, but the customer doesn't really understand how Fibonacci numbers work. It's okay, so now let's start. We're gonna write some code. First, I'll show you, again, I don't know how deep you are, so I'm expecting that you are the juniors, for example, so I'm telling you how does unit testing works in general, automated testing, so what it is. Let's say this is our function. We're very silly programmers, very lazy, not silly, but lazy programmers, so we design it the way we understand. If the input, whatever the input is, we just return 0. So in a very corner case, on the first number, it's going to work, right? So if the input is 0, then we return 0. So in a basic scenario, this function works, more or less. And we call it, let's say, fibo.java. So this is the source code, live code. Somebody calls it live code. For the live code, it gets compiled, to fibo.class. This is how JDK works. So we have the source code gets compiled into class, it's called bytecode. So this code is ready to be executed. On the other side of the picture, we have a test. So I wrote a very simple test. This is called unit test, automated test. No matter how you call it, it's a test. The test is also a piece of Java code, which makes the first line says assert, the second 4 lines is the same as the first line. So we basically, I'm just giving you 2 examples. You can make the simple example, the first line, or a more complex example, which is below the line. So assert means that the expression after the assert is true, always true. So if you run the code, which you see on the right side of the slide, it has to pass, it has to go through without mistakes. So this code works. If you call fibo with the 0 as an argument, it returns 0, so everything will be fine. 0, fibo 0 equals to 0. Our very lazy code perfectly works with a very lazy unit test. So we also compile this test to the binary code, to the bytecode. Yeah. I did 2 checks in order to show that they're equivalent. They're the same. You can use assert, or you can use more, to explain what is assert. So assert is assertion, which is like a Java-specific instrument of checking that everything is okay. The second example with the if is more generic, so it will work not only in Java. So in C, for example, in Python and Ruby, they don't have asserts, so they need to explicitly say if something equals to something. If it doesn't equal, then you break. So the idea of a unit test is actually to run the live code to check how the code works, and if something is happening there unexpectedly, then the test code should fail. That's the idea of an automated test. So we also compile it. So now we have 2 pieces of code. So we have the code which is the live code, and we have the test code which is the test code. Then we package them together. Then we put them together in one package. They stay together, test code and live code. And we run this stuff. So we execute, of course we execute the right side. So we execute the tests. The live code also only helps the test code to work. And what we get in the end, we get test log. So we get information about what tests fail and what tests didn't fail. So if none of our tests, we just have 1, if none of our tests actually fail, then we are perfectly safe. So that's the idea of unit testing in just 1 slide. You write live code and you write test code. The test code, you run it sometimes in order to see how the live code works. If you don't have the test code, only live code, then basically this job will be done by your users. So you will give your product to users, and they will run it on the mobile phones or wherever they run it, and they will see the bugs. So in order to prevent that, we don't want our users to see the bugs, so that's why we create unit tests. So we create tests which run and test our code on our computers, and then we'll look at the test log, and everything is great. I think this is obvious. This information is pretty fundamental and basic. And now we're getting to something more interesting. Let's imagine, and the release pipeline. One more slide to explain how this testing goes into the development cycle, how programmers work in practice. Because I work in production code, with production code a lot, so this is how we do it in practice. First of all, we understand the requirements. We programmers will look at what requirements are, like the customer said, we need Fibonacci number, so we understand what it is. Then we create a branch, then we write a code, then we commit, and then we push to the branch. Probably, who here doesn't know what is a branch in Git? Perfect, so you are really programmers. So we create a branch, we push to the branch, we push live code, we push test code, it goes to the branch. Then the branch goes to the trunk of development. In Git, it's called master branch. In some other systems, it may have different name. So we merge our stuff. Why do we do this? You probably know why we need branches, because sometimes we have many programmers, and we don't want programmers to clash their changes, so we want them to work separately. Each programmer works in her own branch, and then they go together into trunk. So we merge them. After we merge, we package this stuff. So we take the code from the master branch, we package it, we create this jar file like we had before, so we package it together into bind code, and then we deliver it to the happy customer. This is more or less a build pipeline. You start with understanding what you need to do, then you code it to the branch, then you ask somebody to merge this stuff into master, then you or the tool take it from the master branch and packages and delivers to the customer. And the customer is super happy. Sometimes. In most cases, customers are not really happy. In most cases, customers, users, you name them, whatever they are, maybe they're fellow programmers, maybe they're your friends from another department, but they're not happy, in most cases. It's very, very unusual when the customers are happy. And what they do, they send us bug reports. This is the core thing, how we communicate with our customers. We get bug reports from them. They say what they don't like. They send this stuff to us. And what do we do next? We start again. We look at these bug reports, and these bug reports are new requirements for us. Usually when the project starts, requirements are very, very vague, like very unclear. We don't know really what customers want. And sometimes customers don't even know what they want, like in the Fibonacci examples. They give us something, and then we start coding, and they run the full cycle. We deliver something to them, and they come back to us with bug reports. And then we listen to bug reports, and then we improve the code, and we run this cycle again, and again. My point is that the faster you run this cycle, the better. So that's the key thing which most programmers miss. So most programmers think that customers should only see good code, that our job is actually to prepare everything here, and only when it's ready, we give it to the customers. That's a wrong misconception actually. So we need to make sure that the cycle runs very often, very, very often and fast. So usually the cycle should be less than a day. So you code, you put it, you release it, you see the customer feedback, you get the bug report, you start coding again. The faster you run this, the better for your project. That's the idea. This is called release pipeline, basically, release cycle, CI, CD, whatever. There are many names for this, but I call it release pipeline. And now I'll show you this release pipeline in a practical Fibonacci example to see like what I mean by fast. Like I'm saying, it should be fast, but probably not everybody understands what exactly is fast. Like how can we make it faster than it is? I'll show you how. Now we will see some codes. So we have requirements, Fibonacci number, let's run it. So we write the code. The first very simple example of the code. This is function Fibonacci, which takes the input, 0, and returns always 0. Yeah.
If you go back, basically you don't have requirement to produce a Fibonacci number. You have the requirement to compute something what user called Fibonacci numbers.
Exactly. Yes. We produce something that user...
The original sequence is correct.
Maybe, yeah, we don't know. Yes, exactly. So we write our first piece of code. It works because we have just one simple test. That's how we understood it. We're lazy. We just make something. And we want the cycle to be fast. So we don't spend a minute more. We just put it to production. We put it to production and we call it release 0.1. It is in production. We release it to the customer. And maybe the customer is happy. Or maybe the customer is dead already and we just walk away and that's it. We get the money, close the project, that's enough. But no, the customer says, hey, hold on. How about Fibonacci 1? It has to be equals to 1. The customer says, makes the bug report number 1, and the bug report says, when I run it Fibo 1, it returns 0, so something is wrong. What do? We say, okay, let me spend some time, and I write extra 2 tests. I a little bit improve my code. You see, now my code is even better. I say, okay, you want 1, you will get 1. For n number 2, okay, I'll give you 1 as well. For everything else, I give 0. Are you happy now? I make release 0.2. Fast. My goal is to make it fast, not to make it good. My goal is always as a programmer to make it as soon as possible to the customer and satisfy the tests. My test suite is very short right now, but it's enough to test my code. So I deliver to the customer. The customer says, you know, I'm not happy again. When I run, the customer comes back to me with 2 bug reports. The bug report number 2, the bug report number 3. And the customer says, you know, for number 1, it doesn't work for number 3, and it doesn't work for number 11. So I get 2 bug reports. So again, the team stops doing what the team is doing and starts fixing the bugs. My goal is always to fix the bug, not to write the code, not to make something great, but to fix the bug the customer wants me to fix and close it and deliver to the customer. So I'm making release number 0.3. Read the code. So in this case, getting to actual implementation of the code. So only after 3 releases, being motivated by 3 bug reports from the customer, I did. I already have 5 unit tests. You see, assert, assert, assert. So I managed to write 5 unit tests. Not because I wanted them, but because customer told me that, hey, you forgot this, you forgot this, you forgot that. So my code base grows. The amount of tests now is probably bigger than the size of my code. Why? Because I was always interested to make this cycle faster. I was always pushing the code to customer faster, as fast as possible. So now the customer is more or less happy. I have more tests. So maybe at this point of time, the programmer actually started thinking, okay, what is Fibonacci number? So maybe in the first 2 releases, the programmer didn't really care what Fibonacci numbers were. The programmer just gave just a few numbers just to get rid of the customer. But now, programmer is thinking, yeah, you found a bug?
Yes, there's a bug.
Yeah.
N equals to, it won't pass the
Equals to 2, Fibo 3 equals to, which line is a bug? Oh, if n...
Second and third. It won't pass the Fibo of 2. Why? Because it will return 2. N equals 2, then return.
There you go, you found the bug. You see, I didn't see it. There's also a bug about number 9, yes, yes. You see, now, in the second part of the session, you will produce good results. The books are waiting for you. So there are still bugs, and the customer is looking at this, and then customer comes back with a different bug and says, and how about, this is interesting, how about -10? The customer comes with something unexpected. We didn't expect that, -10. You didn't have it in the requirements. How come, why do you expect exceptions here? Because our code is going to return what, -10, right? But the customer suddenly improves the requirements and says, we expect with the negative number, we accept an exception, but your code doesn't throw an exception. So now we say, okay, requirements are changed, and we release 0.4. We add one more test to our test suite, we make the code larger, now the code returns, throws an exception if n is blah, blah, blah is negative.
Throw a second overflow exception. Because like it's not limited the bottom, so it will grow recursion until it will eat all the memory. It will throw it away.
No, if n is less than is less than 2, that it's going to return n. I think I think it's pretty safe. But still, maybe. So you see, the requirements, my point is that we are always driven by requirements from the customer. We are bug report driven. We are bug driven development. That's the key idea. Our goal is always to push our code away, not stay with it for longer than it's needed. That's the idea of build cycle being fast, release cycle being fast. Don't hold it in your hands. Push it to the customer and wait what the customer says. When the bug reports comes in, perfect. Maybe in this case we stop. Maybe the project is finished. Maybe the customer asks something else from us. We don't know. But I added one more example. Maybe the customer comes to us and says, the customer is very attentive to details, and the customer is the programmer all of a sudden. The programmer says, you have too many return statements. There are some people who believe that it's not good to have in the code more than one return statement. You can read some books about clean code and you will see that some people recommend that. They will tell you that if you have more than one return statement, then your code needs refactoring, that you're doing something wrong. There are people saying that, so our customer is one of those people. The customer wants our code to be cleaner. Functionality-wise, the customer is happy, but in terms of the formatting of the code, the customer wants us to be cleaner. So what do? We say, okay, all right, I refactor my code, and at the bottom, I add one more thing to my build, to my test suite. I introduce static analyzer, which will, for the future, in all places, make sure, PMD, for example, PMD has a check, PMD is a static analyzer, which will check that every time my code has only one return statement. So we have release 0.5, and it is more or less okay. So you see how we went through very small piece of code, which was also more or less okay, to a larger piece of code, which is much bigger. If we continue this way, there will be more and more releases. And some people say that it's endless line of releases. You can always improve your software, even if it's a small piece like Fibonacci. So in this case, you can say, for example, recursion is bad. Some people say that recursion is a bad idea in general, because it's going to be quite slow. So if you run this code with a number, instead of 11, you give it a number 100, then maybe you're going to get Stack Overflow, even on Java. So this code is not perfect because there is recursion. So there should be another approach to this. And so on and so forth and so forth. So there could be unlimited number of bugs, even for a simple software. And our goal as a programmer is always try to just get rid of the bug and let it live. And always, when the bug comes, that's the final point I want to make, is that when the bug comes, before we fix the code, we introduce an extra test. So every bug which is coming to us has to be the motivator for an extra test. That's very important. So that's how we grow the test base. You see, the amount of code now, we have the code, and then, what's interesting, then when it goes more and more and more, then the amount of bugs will grow, and then you will fix them, and then maybe in a year, after your software is alive for a year, you will have like 200 bugs closed already. And in this situation, the amount of code which is test code, comparing to the amount of code which is live code, will be much bigger. So you will have many more lines in the test suite comparing to the amount of lines in your live code. And that's the indicator of a good project. If it's the opposite way, then it's a bad project. So if you have more live code and less test code, then it's a bad project. It means you don't pay enough attention to bringing your code to the customer or listening to the customer. So the code base should grow, the test code base should grow. So that was my point, basically about tests. I can say a few words more about we have like some time. So what is a valid bug? This is very important because many people misunderstand this. So many people think that bug is that something is broken, that something doesn't work. Like you said, like functionality bug, they call something that's really broken. But as you saw in the example before, when I want the code to be improved, like maintainability-wise, readability-wise, it's also a bug. So I suggest 5 types of bugs, which in my opinion are all valid, and they should be reported. And actually, in our second part of this conversation with us, when I'm going to give the books, the first book will be for those people who will create the most interesting bug. So I will give the gift for the bug report. And the second gift will be for something else. So a very good bug report is a valuable asset for the project, valuable contribution to the project. And there are 5 types of bugs, in my understanding. The first one is functional. It's pretty obvious. FIBA 0 not equal to 0, that's a bug. If something doesn't work functionality-wise, it's a bug, everybody understands it. The second type of the bug is code style. We saw it before. Too many return statements. The line is not indented right. Something is wrong with your parentheses. Something is wrong with your amount of code, size of code. Too long method, too short method, and so on. Style, it's called code style bug. So everything is fine, the code works, but the style is not perfect. Number 3 is missing feature. For example, somebody comes to us and say, I want the functionality FIBO with a string as an input. Not a number, but a string. And I expect your function, to convert it to number. That's my requirement. It could be an interesting addition to... No, it's not a function. The functionality works, but the missing functionality. So what we have, the first type of bug is that the functionality which you have right now is broken on some input. So you give some input and it breaks. Here, well, you're not going to compile FIBO string in Java, so you cannot even, so this functionality is not provided. So in Java, each method with a different type of parameter, it's a different method. So let's say they say, I want another method. I want another function which accepts string, a text. And then I want your function to convert it to number and then do the calculation. So it's a missing functionality, and it's also a bug. So when you look at the code, you can always find bugs there, because missing functionality is also a bug. So look at our Fibonacci number. You may say everything works fine, it calculates the Fibonacci number. No, there's a missing functionality there, potentially. Yeah?
Can we say that it's all technical debt?
Technical debt as well. Yeah, we can say it's technical debt.
To me, bug is only
The first one, yeah. In my understanding, they're all bugs. I will see now 2 more categories, and they will be more controversial. So in my opinion, it's all bug. We just call them bug because they all go to bug report. All of these 5 things, they should be converted to bug reports, which are, as we understood before, is the input for the project. Number 4 is maintainability. Yeah, sorry.
I'm sorry, missing feature. It just in accordance with the requirements. The requirements were that FIBA accepts integers. Period.
This is the bug and requirements. This is the bug and requirements. Let's put it this way. This is, yes, that's right. I would say it's a bug and requirement. So you didn't, I have some more requirements. For example, with the throw exception. My customer, of course, yeah, that's one group, of course. Yes, of course. Well, I think it's one group of people, so we all work together. So the project has new requirements. The project has new needs. And then somebody comes into the project and says, these are my needs, and I report them. I call them bug report. And then the project decides what to do with them. Maybe the project will say, no, we're not going to introduce this new feature because we have different plans. But suggesting these features, I think there are also like bugs in scope. For example, the exception throwing, like -10, supposed to throw an exception. Where is this feature? This feature is missing. So we need this feature. How about string? Where's this feature? This feature is missing, so we need this feature, and so on and so forth. And the next one is the maintainability bugs. For example, I don't understand how FIBA works. That's a maintainability bug. So I cannot maintain this code. I'm a new programmer. I open your code base, I read your code, and I don't understand something. Why? Because the code is messy, the code doesn't have documentation, the code doesn't explain itself, blah, blah, blah. This is maintainability bug. It's not my fault, it's the fault of the code base. The code base needs to be improved, and I report it.
So, regarding the result of people of 0 is clear, it can formalized. As for the other kinds of bugs, so let's say a person comes to you and says, I don't like the indentation of this one code. Okay, but there are 10 people who like it. So how do you understand?
That's right, yeah, that's right. So any bug is valid as a bug, but it doesn't mean that any bug will be accepted by the team. So the bug is reported, we have the bug report, and then the team, or in the perfect situation, the architect of the team makes the decision. Do we accept this bug into our backlog? Do we start working on this bug? Or we just ignore it and delete it? So in some cases, we just say, you know, you don't like the indentation, but we have 10 people who like the indentation, so thanks for reporting the bug. No, we delete your bug, and we close it. It happens a lot in open source projects. Try to go to some big open source project and suggest something there. Missing feature, maintainability problem, code style, you will see what they tell you. They will delete your bug in 99% of situations. But you can still report it, and you continue reporting. And maybe sometimes they will accept it. So the smaller the project, the bigger the possibility to report bugs. Of course, the more mature is the project, the more difficult it is to report something there. So if something is not clear, it's maintainability bug. And the final one is coverage. I look at your code, I suspect there's a problem there because there are no tests that cover that place. There's no bug, I cannot prove it right now. I'm not sure there's something is broken, but there's the code, the test is missing. So probably there's something is wrong. So basically I call it coverage bug, so not enough coverage. And of course, the team should consider that and should say, okay, sure, we're going to cover that with the test. We did it. We closed your bug. We didn't find any other bugs there, so everything was perfect there, no problem. Thanks for reporting the bug. The code was improved. So I'm showing you these 5 because now we're going to make a competition who reports the better bug. So think about all 5 possible types of bugs which you will report to open source repository which I created for you. To summarize, so if you look at your projects, what's going on with you now, remember that you have to run this cycle faster, release faster. So first of all, the first release, that's the first principle. When I look at software project, I decide whether people are doing proper development or not. The first one, the first release, when you start something new, should be delivered to customer in 2 weeks or less, even 1 week. So when the project takes, you know, we're going to develop for about 6 months and then we show it to the customer. In 6 months, we're going to have the proper result. It's completely, people don't understand what they're doing. Something small, something deliverable should be put to production, not maybe to production, but to staging, like in the hands of the customer in just 1 week or maybe 2 weeks, not more. So first you think about running this cycle faster you can. Second one, each next release should be delivered like every week or maybe even every day to the customer. So the sooner you put it to the people who look at your product, the better for you because you will get more bug reports. Next one, you do only what bug reports say. So if you go to a real team in production and I ask some programmer, like, what are you working on right now? And the programmer says, we are improving. I'm saying, what is the number of the bug you're fixing right now? Oh, I don't have the bug. I'm just developing. Then something is wrong in the team. So every programmer should work in any moment of time on the number, on the bug report, which has a number. In this case, the team is properly disciplined. So all the things we do, except the period of the first 1 week. So during the first week, we don't have bug reports, we're just improvising. But then after that, we start only listening to bug reports. So every time you do something in your personal project, in your GitHub project, in your open source project, every time you want to do something, first make a ticket and explain, I will do this. And then you start working on the ticket number 17 or something. So make bug reports for yourself even if you are alone in your project, if there is nobody else, but still make it a discipline for yourself, like a habit. So every time you work on something, there has to be a number of the bug report you're fixing. Maybe make bug reports for yourself, but out of these 5 categories. And of course, like I said many times, you have more tests than you have production, than you have live code. This is the indicator of a good project. If it's not this way, then again, something is wrong. And now, a little philosophical summary. So some people think that we make it perfect before we give it to users. Probably now you understand that that's a false objective. So this is not how it should be. You don't make it good before you show it to the user. Instead, you give it to users in order to make it good. So you only can make it good by giving it to users, getting bug reports from them, fixing those bug reports, and then the product is perfect. So understand that your users, and somebody told me many times that it should be users, that could be other people, like other programmers. It doesn't matter who they are, but they are providers of bug reports. Make your friend a user. For example, you're developing the product, but show it to somebody, show it to testers, show it to users, show it to customers, whoever they are. But they are the providers of bug reports who you fix, and then you create automated tests, increase your test code base, and so on and so forth. I will give you one practical example, which I had just really about a month ago. It's a real practical project which we are working right now on in my company. We have the task which is called create a translator from one language to another. So we take the one programming language and we expect another programming language to be created. It doesn't matter, just one text to another text, a translator, which is supposed to translate different things from this input and produce the output. It's a very complex project for about maybe a year, the long duration project, production for a lot of money. So we asked the development team, so make us a plan, so how this project will be organized. And this is the plan they come up with. So they said, okay, 3 months we're gonna analyze what to translate to. Another 3 months, we're gonna suggest the method of how it will be mapped, right? We're gonna think together and suggest how we're gonna map the source information to the target information. And then another 3 months, we're gonna implement. There will be 34 different things in this source data, and we're gonna make sure that all of these 34 elements properly map to the target. And another 3 months, we're gonna validate the implementation, write some tests, and make sure it works. So I think now you understand that that's wrong, right? That's a wrong approach. Because in this approach, we're gonna see the production code in 9 months. So we're gonna wait for 9 months before we show it to customers. You see? So we suggested a different approach. Probably you already understand how you would draw this map in a different way. So we did it the right way. The right way it looks like this. 3 months, we correctly translate 2 features out of 34. So give us something which translates only 2 features. Don't do 34. Make it some draft, make a skeleton, make a simple implementation of 2 features. 3 months, give it to us. We test it, we play with it, and we report to you bug reports, and you know what is wrong. And then another 3 months, you make 10 more features, another 3 months, 20, and by the end of the year, you get 34. So that's really example from life. It's a contract, really, it's happening in real life. So people think this way, we're trying to tell them that this is the better way. Incrementally. It's called iterative development, iteratively, not increment, iteratively. So we iteratively reach the goal. Yes?
A quick comment. I wouldn't say that the first approach is wrong, whether the second one is right. These are just two possible approaches.
Right.
Nothing else.
Yes, exactly.
Because the first one is definitely not wrong. Sometimes when a project has a kind of very big design part, we need to spend much more time to design the system instead of implementing two or three features. It is often not possible to just to limit yourself by two features. We should think about how the whole project is organized. So, again, both approaches are
Possible.
possible
Right.
to consider.
Right.
So, my suggestion, to rename road to left.
Left and right. Okay.
And I have a question about architecture.
Architecture.
About architecture, because actually in the website, as Evgeny mentioned, that in this case you can try to implement the architecture for the whole system. In this case, how do you handle this? Because it might be that when you implement the architecture for two features, you need to completely rebuild your system.
Exactly.
What can you say about this?
Yeah, I think it's good that you rebuild your system after 3 months, not after 9 months. So the sooner you make the mistake, the better, probably. Of course, sometimes there are situations where thinking about architecture need to take 6 months, but I suggest to try to make its interval shorter, as short as possible. 6 months is too much, in my opinion. So even if the 3 months, you make something for two features, and then in the next 3 months, you realize that you made it wrong, because there are other features who need a different architecture. Then you rewrite it again. In my opinion, this waste of time is better than the risks we take on the left approach. On the, not wrong, left approach, yes.
Again, quick question. Why we are so hurried to just be so quick to provide the customer with just two features? Why? To make the customer happy, to make him sure that...
To listen to customer. To listen, to let the team listen to customers and then be driven by bugs. So we need the feedback, as soon as possible.
So I guess the right approach once the design stage. I think the first 3 months should be divided into 2 months and 1 month, where the first 2 months is the design of the basic architecture, and the rest is the implementation according to the design architecture.
Yeah, good comment, but I think that the design should happen on the background. So you cannot, as a developer, design for two features, design architecture without making the design. So without thinking what is the design. So you have to do it. So it's like I don't know. We need to drive to Kazan and then drive to Moscow. And then where is the shifting the speeds? Well, actually, when you drive, you shift your speeds. That's happening automatically. So you don't say like you shift to the first, you shift to the right. So something happens on the background. So we just say drive this way and drive that way. So architecture, design, testing, analysis of the requirements, delivering, configuring the pipeline, installing Git, installing Windows, configuring your computers, all of this stuff, having meetings, talking on the meetings, going to the office, going back, sleeping, eating, all of this stuff is happening on the background. So we are just identifying your milestone, but we need something to identify the milestones. So the left way, I think, is more about saying that we're going to sleep, we're going to go to the meeting, so we're talking about the wrong things. On the right side, we just incrementally, iteratively focus on what's important for us.
And your approach is not walking to Moscow rather than driving,
Yeah.
and then maybe catch a car. Instead of spending 2 minutes searching for a car and driving.
Maybe, yes. In my approach, you start walking, because it's faster, because you just immediately, okay, whereas Moscow, we just start walking, and then you realize in some time, in a few miles, in a few kilometers, you'll realize, how about we call a car? Yeah, you will do it. But maybe at that time, everything will be done already, I don't know. Maybe you will decide Moscow is the wrong destination. But in your approach, you call a car, book a ticket for a first class flight to Moscow, and then you sit in the plane and realize, oh, come on, it's the wrong destination. We should fly to another city. So I'm suggesting start walking, and by the way you walk, you think, where are you walking? So it's a good metaphor.
So I think this lecture would be really great to dismiss all these questions and have a disclaimer saying, I will be talking about projects, which means, for example, web development projects, not just software projects, not language scripting projects, not the things that can be easily fixed, easily failed, and repaired.
No, actually, our projects are not web projects. We do research projects, and we apply this philosophy to practical... No, we do airplanes with this approach. Why it's not right? In Huawei. No, I think this approach is called agile, so it's not my idea.
My limited experience is showing that if you do research in the right manner, I mean on the right side, it may be impossible to do even features in all of this year, because if you don't proper previous or prior research, you will not be able to even say if it's possible to implement current hardware, software, etc. So you need to find some analysis before starting to even have the ability to say it is possible. If you're looking at web projects and backend stuff like this, almost always they have something possible. So they show this framework as an actual field. You say, okay, my experience is this is my position, you can doubt it, speak, and when I say project, I mean something that can be easily.
No, but that's wrong. It's a wrong disclaimer. It's not true. I think this is applicable to real projects. Actually, I'm taking this idea from rational unified process, from IBM. The correct, no, I don't need this. I made a disclaimer that you can doubt what I'm saying, but this concept is coming from IBM, rational unified process. I don't think IBM is doing small projects or web projects.
You're relying on some iterative. So if you say, if you try to prove your statement with the authority of IBM.
No, I'm not trying to prove. You're saying that this is applicable only to small projects. Yeah, it is not true. It's not applicable to small projects. And as a counterexample, I'm giving you the source of this idea. It's just coming from IBM. So probably IBM is doing not only small projects. I'm saying to all projects, yeah. To all. This is what IBM is saying, so I'm repeating their idea. Rational unified process, try to read it. That's a concept which is 30 years old. It's called iterative and incremental development, so it's not me improvising. About all projects, I'm not completely sure, but they say that, they say for all software projects, for most. Of course, there has to be a balance. Of course, in some projects, you may not deliver the first version in 2 weeks. But how many projects like this? I haven't seen many in my life. In most projects, I've seen code where something can be delivered in 2 weeks, something, in most cases, less. So you open the code, you configure the pipeline, build pipeline, you put a few classes, you make sure they all compile together, and boom, next day, or maybe 2 days, something is right there. Then you make a little bit of changes, some functionality, boom, you put it to hands of the customer. And the customer says, look, that's completely wrong. You say, okay, we changed a little bit. And then you start thinking more about architecture, more about design. So you iteratively increase, like if you take a look at the rational unified process, they increase the amount of effort you spend on design and development like this, and then you goes down. Then you increase for the architecture and it slows down. So they put like they have this 9 lines of activities. They call them activity lines or something like this. So 9, implementation, design, architecture, testing, deployment, documentation, and project management. So they're like 9 lanes where you swim. And when you start the project, like for example, implementation is 0, but design is more active. And then the implementation goes up, and design goes up, and then design goes down in implementation. But they all go in parallel. And on this flying lanes, they ask you to do incremental deliveries every week. So you cut it by the end of the week and deliver something, even though you spend on implementation like 2 hours and on design 2 hours, but you need to deliver us something. Again, another week, you spend something on each of these activities. You deliver us something. That's IBM approach. I just made it more simple. Yeah, that's what the point Evgeny made, yeah. Yeah, we agreed, it's left and right, yeah. It is waterfall, it's more waterfall, yeah. And some people say waterfall is okay for large projects.
Question or maybe one. It seems to me that maybe you use a wrong title for your lecture. Instead of unit testing, it should be test-driven development. Is it correct?
Test-driven development, yeah. Or I would say bug-driven development, test-driven development. I would say iterative development, yes.
Again, also comment. I would suspect that the example of your project is not appropriate to just a comparison. I mean what? Typical task description for creating a translator from one language to another assumes that both source and target languages are specified. They
Exactly, well specified, very fixed from the very beginning.
They're very fixed. They are international standards, for example, or de facto standards, as in case of Java. So customer won't change his or her requirements quite often because they are precisely specified in the documents, in standards, etc. Assembler, Intel assembler is fixed. It doesn't change during your project. So why to provide the customer the first draft result in 2 months? I don't understand. I don't understand. Or probably the customer that is not sure that I am able to implement the project.
By the way, maybe it is not always true, simply because like yesterday, we had discussion about, let me say, development language. And basically, we have
This is another point. This is exactly the point.
Even the bug report where it is not. You remember yesterday, we had a meeting.
Yes.
Or
Tuesday.
That it was yesterday. So,
the
language is not fixed yet.
The approaches can be very different.
Could be very different,
I
yes.
was talking just about your
Scope definition.
Yes.
Yes. Yes, in real life you will have different situations, of course. There are good points, definitely. You will have different situations. Sometimes you will spend more time on design, more on development, but try to, if it's possible, try to be quicker in delivery if possible, of course. Sometimes maybe there are situations when you need to really think about design for longer. Maybe the customer says, wait, we will change requirements. So how about you wait for a few months? Sometimes it happens, yeah. But in general, if it's a simple project like web design, like you need to faster, so do it faster. So
I respectfully disagree with what you said two valuable colleagues before. Because I personally think that the part of delivering back even a partially defined solution is to gather knowledge from the customer, which is very hardly formalized and very hardly definable in terms of what you said, written documents, right? Because I never saw a document which fully described a piece of software. And since software is about knowledge, giving document to the customer early is a way to get knowledge from the customer, knowledge which cannot be formalized in terms of just written text.
Yeah, and probably collecting knowledge is sometimes or very often easier when you have a product. So if you show to the customer a product, it's one story, yeah. But if you show what you want, then the customer may not understand. So working with the document and working with the product, usually for us, for example, sometimes in this situation, we are customers, so we definitely don't know exactly how to do the translation, but it's easier for us if you show us something in a few months, and then we say, that's wrong, do it differently. Instead of asking us, provide documentation, explain your requirements, we will be very lazy in this case. So collecting requirements from the customer is very iterative project and stressful for the customer. Last question.
Sorry, it's not a question.
Okay.
So somebody online cannot hear the comments.
I will repeat the comment. Yeah, okay.
So I think it's important to implement something fully as soon as possible, simply to gain confidence that you have the ability to implement the rest. Because before you have something.
Yeah, it's a good comment. So the comment is that sometimes we get extra confidence when you implement something faster, and then you put it to production or to staging. Then you're more confident that the project is potentially could be successful. So, guys, we are limiting on time. So this is my final slide. I suggest you to read these books, 3 books. I just something to give you. So these 3 books really helped me to understand this concept. I read them with a lot of satisfaction. So these 3, make a screenshot. And after that, we go to the small break of 10 minutes. And then who other programmers can stay? We're going to have a small, I hope, interesting competition. By the end of the competition, I will give 2 books. First book is to the best bug reported, and another book to those who will manage to merge the biggest amount of pull requests to the source code which I created for you. So this is the repository on GitHub. You can open it now before the break. So you have 10 minutes to research it. This is the name of the repository on GitHub. So open it up. This book goes to the best bug report. This book is called Object Thinking. In English, both books. So this one, you will have exactly 45 minutes. This is the rules of the game. You will have exactly 45 minutes after the break. You just go to GitHub, you look at the code. There are 5 classes in Java, very small, very primitive. You submit bug reports. The most creative bug report, the most interesting, the most valuable, will get the book. I will be the judge. And the second book will go to, this is my book, called Junior Objects. This one will go to the biggest contribution, which I will count by the amount of pull requests. I will merge your pull requests. So look at the codes, and remember that the pull request should always be connected to the bug reported. So before you start working on changing the code, you have to make the bug, explain what you're going to change. Then I will have to accept the bug. So I will accept bugs by adding the bug tag there. So you report the bug. I put the bug badge there. If the badge is there, you can start working. You can say in the ticket, like, I'm working on this bug. Then you make the pull request. I merge your pull request. And you get the point for the pull request. So we have 45 minutes, which will give you practical knowledge of how unit testing works. The code is a little bit covered by tests. So we have 5 Java classes and only 2 tests. So potentially there's a coverage problem, like we discussed before. So we are ready to start a short break, and then after the break we start. I'll be sitting here on the computer, and you will see how I review your pull requests and your bugs. So it's all going to be live presentation. Okay, thanks for listening. 10 minutes, then we continue.